Hello, my name is Ben Josephson, and I'm a student at the University of North Dakota in the Distance Engineering degree program. Today I'll be demonstrating for you my PCB project for EE309, the Junior Circuits Laboratory. The intent behind my design was to create a circuit board that could control the output to a series of colored LEDs. Ideally, I'd like to use this control board to control a larger lighting circuit that would simulate the effect of a sunrise. So the intent of the design is to slowly illuminate each LED, starting with the blue one, followed by the red one, followed by the orange one, and followed by the yellow one, slowly fading each LED from complete darkness to its top intensity. The circuit is designed in 3 different phases, or stages if you will. Obviously there's one stage for each color, and then the initial stage of the circuit consists of a 555 timer and an RC circuit that's adjustable to control the timing of the second stage initiation. The second stage then is a MOSFET common source amplifier that slowly increases the voltage to the LED and correspondingly the brightness of the output of the LED. And then the third stage consists of each, it's an on-off circuit, the power source, and each subsequent stage based on the lighting color. The initial design was done in multi-sim, and in front of me here is the model. I will go ahead and initiate it by pushing the space bar to close the switch, and if you watch closely you'll see that the LED that is first in line here, the blue LED, will illuminate. There it goes. This will be followed by the red, the orange, and the yellow. I had to change some of the resistive values in this simulation to speed up the process a little bit for the purpose of this video so that I could fit everything into the allotted time of 5 minutes. So there you can see the circuit is completely illuminated, and operation is as desired. In order to fully complete this project, I needed to design the circuit and transfer the design to a actual printed circuit board. This was done by exporting the multi-sim design to the Altiboard program, where I could set up the layout. Here you can see the finalized layout where I spaced the components out in order to minimize the traces and the distance between the traces and reduce some of the clutter on the board. You can also take a look at the 3D view that Altiboard generates, and here you can see what the finalized design layout would look like once it's constructed. So you can compare this to the actual output of the board that we have over here, the final designs. I built 2 different boards to demonstrate the process. The first board that I built, the initial parameters for my resistance and capacitance and my time delay circuits was a little bit too small, resulting in the functioning of the board being a little faster than I desired. So I'll go ahead and I'll demonstrate that now. When I initiate the input to the 555 timer, you can see the LEDs light up in sequence, but much quicker than I intended. So I went back to the drawing board, I changed some of the parameters for the resistors, and the final result was what we see here in circuit board number 2. And this takes quite a bit longer, and the growth of the intensity of the illumination of the LED is much more as I envisioned and desired. So those adjustments, part of the design process, led to a final product that operated the way I intended it and much more like the model. There you can see the blue LED has reached its full intensity, and here shortly we should see the red LED start to illuminate. And that will then be followed by the orange and the yellow. And obviously this combination of resistors and capacitors created a much closer simulation as would be expected from the simulation. There comes the red, again slowly growing in intensity as it comes on, followed by the orange, and then finally the final stage of the circuit, the yellow, you can see start to illuminate there. So the model got me to this point. I was able to send the file off to the manufacturer and have the boards built. The process went relatively quickly. I was impressed by how fast the boards arrived. I assembled them and did some experimentation, determined I'd have to make some changes, so I did, but the ultimate end state is that the board operates as I intended, and this was a successful project for me. I hope you enjoyed this presentation, and thank you for your attention.